All right, picture this. We're on a massive drill ship, holding position in deep water, right over a live well. Suddenly, a genuine emergency is detected. Maybe it's a major fire or a significant gas release. Well, there's a system on this vessel whose entire job is to override normal operations the very instant that happens. It shuts down ventilation, it stops fuel and lube transfers, and it can even kill the main engines. And it does all of this zone by zone without waiting for a single human decision. That system is the ESD, the Emergency Shutdown System, and it's deliberately entirely independent from the standard automation networks we walked through in episode 7.1. Welcome to episode 7.2 of this explainer, where we're going to unpack the system that literally overrides everything. Here is our roadmap for today. First, the big red button myth. 2, the zoned and categorized response. 3, the 4 ESD zones. 4, the shutdown matrix. And 5, how scoped shutdowns actually save lives. Let's get right into it. Section 1, the big red button myth, precision over panic. To really grasp why the ESD is so critical, you've got to put yourself in the reality of an offshore crisis. The very first seconds of a well control emergency or a major gas release are incredibly chaotic, and in those moments, human hesitation is deadly. If the crew has to stop, manually assess every affected system, get on the radio with different departments, and then individually shut down each piece of equipment, they're spending precious time they simply do not have. The ESD exists to completely remove that decision-making time from the equation when the clock is ticking the loudest. Now, this is where a lot of folks actually get it wrong. We all know the Hollywood myth, right? In the movies, there's always one giant master kill switch, a big red button that indiscriminately completely blacks out the entire vessel at once. But the engineering reality is vastly different. It's actually a precise, highly engineered, pre-programmed logic matrix. It scopes the shutdown to isolate specific hazards without accidentally creating new ones. It is absolutely not a blunt instrument. It's a highly tuned safety mechanism. So, let's lock down exactly what we are looking at. The Emergency Shutdown System, or ESD, is fundamentally a zoned, categorized system. Whether it gets triggered automatically by sensors or manually by a crew member, it shuts down very specific equipment groups in response to that detected emergency. Its main immediate jobs are isolating fuel sources and cutting off ventilation. And because it relies entirely on pre-programmed logic, it executes all these actions instantly the moment it's activated. Moving on to Section 2, zoned and categorized response, escalating the action. Let's see how this builds. To avoid needlessly shutting down the entire ship, the ESD actually works in 3 escalating tiers of severity. Step 1 is the ventilation shutdown. Why start there? Because cutting off the ventilation starves a fire of oxygen and stops smoke or toxic gas from spreading through the ducts. Step 2 is the fuel and lube transfer shutdown. This actively isolates the systems that could feed a fire. And finally, Step 3, which is the most severe action possible, is the main engine shutdown. Killing the main power plant is the absolute last resort, and it's reserved strictly for extreme cases. That brings us to Section 3, the 4 ESD zones, the geography of the GF 12,000. Geographically speaking, the vessel is carved up into 4 primary station zones. First, you've got the WH, which is the wellhead area right where the actual drilling happens. Then there's the HQ, the accommodation or headquarters block, basically where the crew lives and sleeps. Next up is the DWS, which stands for the drilling, water, and support area. And finally, the ECR, the engine control room. What's super important to understand here is that each of these physical areas has its own dedicated ESD activation stations. And these stations are physically completely separate from the daily control panels the crew uses for normal operations. I really want to highlight this quote, straight from our source material, because it is a vital rule of thumb. Every crew member should know the ESD zone boundaries and station locations relevant to their normal work area. If a fire breaks out, activating the correct station quickly has to be second nature. Under the massive adrenaline spike of a crisis, you absolutely do not have the time to go searching for a map. All right, into the core of the system. Section 4, the shutdown matrix, where zones meet categories. Now, what's really interesting here is the matrix itself. This is the absolute centerpiece of the ESD logic, perfectly combining our physical zones with those operational categories we talked about. Every single ESD activation point is mapped to a specific combination of a zone and a shutdown category. For instance, if you hit the ESD in the HQ zone, you get a scoped ventilation shutdown, but it completely ignores the fuel or the engines. But if an event triggers down in the wellhead or the engine control room, the logic allows for an escalation all the way up to shutting down the main engines in extreme cases. Basically, triggering one station produces a highly predictable, localized response. Let's actually walk through a quick hypothetical scenario so you can see this matrix in action. Imagine a sudden gas release is detected in the DWS, the drilling, water, and support zone. Watch what the logic matrix does. It automatically triggers the ventilation and fuel transfer shutdown, but only in that specific DWS zone. The HQ block where the crew is, and the engine control room generating the power remain fully operational. It perfectly manages the hazard without needlessly taking down the rest of the ship. And this brilliantly illustrates the whole concept using an analogy we're all pretty familiar with. Think about a modern high-rise office building. If you pull a fire alarm on floor 3, the system triggers the fire doors and ventilation shutdown specifically on floor 3 to contain that threat. It doesn't instantly lock down the lobby on floor 1 or the executive suites on floor 10. The ESD operates on that exact same principle, just scaled up to a massive, highly complex industrial level. Which leads us perfectly into our final section, number 5, Scoped Shutdowns Save Lives. The danger of a total blackout. We've got to tackle the big question, the why behind all this complex precision. In an all-hands-on-deck emergency, why not just shut down absolutely everything, vessel-wide, all at once? Wouldn't that be the safest bet to guarantee you stop a disaster in its tracks? Well, the answer is a hard no. An indiscriminate, total shutdown actually introduces entirely new catastrophic hazards. Think about it. If you kill the whole ship, you instantly lose power to your critical firefighting pumps right when you need them the most. You shut down safe ventilation in totally unaffected areas, which could trap crew members in unbreathable air. And critically, for a deepwater drill ship, you unnecessarily disable the DP3 station keeping systems. If you lose your dynamic positioning while you still have a live well connected to the seafloor, you've just caused a massive secondary disaster. A precise, scoped response preserves the very systems you desperately need to actually fight the emergency. Now, because this system wields so much power, there is a massive, absolutely crucial safety warning we need to pull from the sources. ESD stations and their protective covers must never, ever be treated as inconvenient obstacles to routine work. You never prop them open, and you never block them with gear. An accidental activation causes a massively disruptive real-world shutdown. And on the flip side, if a station is damaged or tampered with, it might fail to function when a genuine emergency demands it. So the ESD matrix is standing by, ready to execute a perfectly scoped shutdown to save the vessel. But it leaves us with one really big provocative question. If this zoned shutdown is the ultimate defense against a disaster, what does the vessel actually rely on to detect that invisible danger, like a silent creeping gas leak, before the ESD even needs to be activated? Well, that requires an entirely different, incredibly sensitive network, the fire and gas detection system. And that is exactly what we're going to explore in the next piece of this safety puzzle.